Bismillah Rahman Rahim. So, welcome to the this lecture. This is all about the artificial nuclear disintegration, and you will learn about the some sort of nuclear reactions, balancing of nuclear equations with the interaction and decay of protons, neutron, alpha, gamma, etc. So the first is the transmutation by alpha particles. Transmutation mean that means the changes of one nuclide to the other nuclide with the decay process, and here we are discussing the alpha particles. So just have a first a look. We will be we will describe in depth in this slide, and then we will move to the other slide by using this knowledge. So here is the general representation of the nuclear reaction. So this is called the target. The heavier or the parent is called the target, and the lighter one or the radioactive particle is called the projectile. And this is the intermediate state. This is called the compound nucleus, and there are the two products. One is the product nucleus and one is the product particle. So the difference between these two products, if the heavier one will be called product nucleus and the lighter one will be called a product particle. So like the example is here. So this is the target, this one is the projectile because this is the heavier, this one the radioactive particle, and it is the alpha, and then it will form the compound nucleus. Further, it is converted into the product nucleus and the product particle. This is the heavier oxygen 817, that's why this is called the product nucleus. And proton 11, it is called the product particle because it is in the lighter. So heavier, lighter, I'm just using the term to easier for you to understand which one is the target, projectile, product nucleus, or the product particle. So here, this is the first example, and this is the short form of the nuclear, this nuclear reaction, or this transmutation by alpha particles. So how can you write the simple notation or the simple form of or the abbreviated form of the nuclear reaction? So within the bracket, you can put the lighter nuclides, and the lighter one here is the alpha. That's why I put alpha symbol over here, and here in the product side is the P, it is the proton. So that means within the bracket, these are the lighter, and this comma actually to differentiate between the reactant side and the product side. So before the comma are the reactant, and this is, of course, this is the nitrogen 714, then it is the alpha, then it is a proton, and this is the product nucleus. So simple, there are two ways to, and 2 points are important. First, before the comma, there are the reactant, and after the comma, they are product. And the lighter one you have to put in the small bracket, and the heavier one you have to show out of the bracket. So this is the simple understanding. By using this concept, you can write the simple or the abbreviated form of the nuclear reaction. Now move to the lecture. So I'm going to show a first example. So what is showing here, alpha P, that means because we are studying the transmutation by the alpha particle, so the projectile will be the alpha. And here we are discussing the example if the product particle is proton, that means proton is released. So with the, this is the actually the particle who is going to bombard on the target, and this is the particle which is the emitting after the nuclear reaction. So that means bombardment of the alpha, there is the emission of the proton. So this is, that's why I have shown in the bracket. And outside, you just mentioned this one is the nitrogen 714, and this one is the oxygen 817, and this is the simple form of the nuclear reaction. So how actually the importance is to calculate the energy released in or the absorbed in this nuclear reaction to decide whether the reaction is exergic or the endoergic. And the third important point is how can you balance these nuclear reaction. So balancing is very simple. That means you just remember the atomic number and the mass number. There is nothing else other than the atomic number and the mass number. So let's suppose I'm going to balance this one. This is the 7 atomic number 2 and the compound nucleus, the atomic will be 9 and 9 is for the fluorine. So a mass number will be 14 plus 4, this is 18. So if the proton is emitted, that means 1 atomic number and 1 mass number. So should be a decrease in 1 atomic number and mass number as compared to the compound nucleus. So compound nucleus you can take as a reference and just multiply, sum of the atomic number and the mass number. It will give you the compound nucleus. And you can also on the product side, you can sum of the atomic number and the mass number. This will also give you the exactly the atomic number and the mass number of the compound nucleus. So this is the way how can you balance the nuclear reaction. So what is important? Maybe I will skip this one, the product nucleus, or maybe skip product particle, or may skip projectile, or may skip the target. If any one of them is skipped, you can fill the blanks by using the balancing of the nuclear reaction. So this is the general equation. So what is happening over here? This is the parent, any atomic number and the mass number with the bombardment of the helium. Helium, of course, 2, 4. And what is happening here? There is the increase of 2 atomic number and increase of 4 mass number, because this is going to actually merge the atomic number and the mass number into the parent nuclide. And then there is the emission of the proton. So 1 atomic number and 1 mass number is going to decrease in the daughter nuclides. So you can take as a reference over here. So if you minus 1 from 2, it will be the plus 1. If you minus 1 from 3, it will be the 3. Or you can just remember, as we have already explained before, 3 plus 1 will be the 4, or 1 plus 1 will be the 2. So in any way you can balance the nuclear reaction. So this is the in depth I have explained here. So I will just move in the coming slide so to differentiate or to explain the other transmutation by the particles. So now coming to the third one objective, that means how can you decide this nuclear transmutation is exergic in nature or the endoergic in nature. So simple, very simple. The other theories are available, but here we will just discuss or we will calculate the energy by using the difference in masses. So this is just the example for this one nuclear reaction. This is the mx, mass of the parent, and the mass of parent is nitrogen 14. It is this AMU. Mass of the projectile, here it is the helium, and the mass of is this. Mass of the daughter, here it is the oxygen 17. Mass is this, and the project particle is proton, and the mass of this. And this is the same formula we have used in the previous lectures. So there is the difference mass of simply the mass of the reactant side minus mass of the product side. So you have to multiply by the velocity of light. This is the E square mc square. Again, there is no need to, each time you multiply with the velocity of light, and then you have to convert this masses to the energy into mega electron volt. So you just multiply 931.5. So this will directly convert the mass into the energy. So this is the energy of the 1.19 mega electron volt of this nuclear reaction. So the sign is minus, and here minus is, which is opposite to the chemical reaction, as I have already explained before. If the sign is minus, then the reaction is called the endoergic reaction. But the understanding is same. That means the energy is required for this nuclear reaction, and this much energy is required, 1.19 mega electron volt. So that means this reaction is the non-spontaneous in nature, because this is the endoergic reaction. Energy is required, and the sign of the energy is in minus. So please remember all this concept in future slides as well. So this is the same transmutation by the alpha particles. We discussed there is the bombardment of alpha and the emission of the protons. And here we are going to discuss the bombardment of the alpha, but the emission of the neutron. And in the similar way, you can balance the equation. This is the helium, 4 plus 2, compound nucleus atomic number will be 6, 9 plus 4 is the mass, that is the 13, and this is a carbon 6, 13. And if neutron is released, and neutron is only contribute to the mass number of the nuclide. So there is the decrease in one mass number as mentioned in the compound nucleus. So this will be the 6, 12. So again, you can just sum up 12 plus 1 will be the 13, 6 plus 0 will be the 6. That means this is the way you can balance the nuclear reaction. And if it is the bombardment of alpha and the emission of the gamma rays, as we have already discussed in the previous lectures, there is no change in the atomic number and the mass number in case of the gamma rays. So just with the sum of the atomic number of the target and the projectile, it will give you the value of 613. And if the gamma rays are emitting, then there is no change in the atomic number and the mass number. So it will be the same as the compared nucleus, carbon 6, 13. So there are the several other examples. You just do yourself and understand the concept for the transmutation by alpha particles. So moving to the transmutation by proton. So protons mean here the projectile is the proton. So first example is the bombardment of the proton and the release of the two alpha rays. So if the parent is lithium, lithium is, and of course, because there is the bombardment of the proton, so the atomic number will be the 4 and atomic mass number will be the 8, 7 plus 1. So atomic number 4 is for the beryllium. So there is the release of 2 alpha rays. Again, 2 plus 2 will be the 4, 4 plus 4 will be the 8. Similar way, you can balance the nuclear reaction. So this is again, I have shown another example. You can use the masses, and here these are the actually the mass of the helium, and there are the two helium. So just this one plus minus mass of the two helium nucleus will give you the difference of 0.01860 AMU, and if you multiply it with the 931.5, this will give you the value of 17.34 mega electron volt. And here there are the two main points to understand. The value of Q is positive. That means this is the exoergic reaction. So exoergic reaction means energy is released in this nuclear reaction. And if energy is released, that means it is the spontaneous reaction. So this is all about the exoergic and the endoergic reaction. So this way is very simple. Actually, you can calculate the energy as compared to the other way, experimental value for Q value calculated for this one energy is 17.33, and by using just the difference in masses is 17.34. So look how ideally it is going to be matched with the just by using the simple calculation. So this you can use any of these example and then decide which are the exothermic or which are the endothermic reactions, and you can take the masses from any reference material. So other way of the transmutation by proton is the bombardment of the proton and the emission of the alpha rays. There is one alpha particles. So again, this is the simple equation. With the bombardment of the proton, there is an increase of one atomic number, increase of one mass number, because proton contributes only one atomic number and the mass number. If there is emission of the alpha, that means two atomic number is going to decrease in the daughter and 4 mass number is going to decrease in the daughter as compared to the compound nucleus. So this is +1. If you minus this one, this will be the -3. This is Z +1 -2, that will be equal to -1. So this is one way. Or another way, if you want to check, -3 +4, that will give you the +1. -1 +2 will give you the value of +1. So this is the same way. If maybe you can take compound nucleus as a reference, and you may just sum of the masses of the atomic number or the atomic mass number of the product particle and the product nucleus to move towards the compound nucleus. And these are the few examples of the transmutation of proton and the alpha particle. There are the other example of proton with the neutron, as bombardment of the proton, emission of the neutron. Again, this will remain the same. And what is happening here, this is because there is only decrease of one mass number with the release of neutron. So there is no difference in the atomic number. So atomic number will remain the same as in case of the compound nucleus, but there is decrease in one mass number as compared to the compound nucleus. So these are the example. You can look 5 + 1, that means 6. 6 is for the carbon, and the mass number will be 11 + 1, 12. And if the neutron is emitted, that means only there is a decrease in one atomic number, decrease in one mass number, and there is no change in the atomic number. So atomic number will remain the same as given in the compound nucleus. It is 6, carbon is 6, but there is decrease in one mass number, which one is the 11. And so 11 + 1 is the 12, or 12 - 1 will be 11. So these are the other examples. So again, there may be the possibility of the bombardment of the proton with the emission of the gamma rays. So with the emission of the gamma rays, there is no change in the atomic number and the mass number. So that proton only contribute to one atomic number and the mass number. So there is an increase of one atomic number and the mass number in the compound nucleus. So with the emission of the gamma rays, there is no change in the atomic number and the mass number. So just have a look on the first example. This is a lithium 3,7 with the bombardment of proton, and this is H11 forming the beryllium, atomic number 4, mass number is 8, and this will remain the same because with the emission of gamma rays, there is no change in the atomic number and the mass number. So in a similar way, these are the transmutations by the deuterons, and the bombardment of the deuteron and the emission of the alpha. So bombardment of the deuteron is the 1 atomic number, 2 mass number. So it will contribute to the increase the 1 atomic number, increase 2 mass number, and with the emission of the alpha, it is going to mass number is going to decrease by 4 and atomic number is going to decrease by 2 as compared to the compound nucleus. So if you sum up -2 + 4, that will be +2, -1 + 2, that will be +1. And these are the examples for the deuteron alpha, and similar way, I'm not going to explain all these. So in a similar way, you can do at your home the bombardment of the deuteron and the emission of the proton. In the same way, you can balance the equation. This is the general form, and this is the real example for the nuclear reactions. And this is about the bombardment of deuteron and the emission of the neutrons. And this is the general equation, and these are the real examples. The fourth one is the transmutation by the neutrons. And as we have earlier said, there are the three different types of the transmutations by neutrons, with the emission of the alpha, with the emission of two neutron, or with the emission of the protons, with the bombardment of the neutron. So it will only increase one atomic, it will only increase the one mass number. So mass number is going to increase by 1 in the compound nucleus, and there is emission of the alpha. So with the emission of the alpha, there is the decrease in 2 atomic number and decrease in the 4 mass number as compared to the compound nucleus. So that means Z minus 2 will be here in the daughter, and A plus 1 minus 4, that will give you the value of minus 3. So there is the decrease in 3 atomic decrease in 3 mass number and decrease in 2 atomic number in case of the bombardment of the neutron and the emission of the alpha. And these are the example. Again, sum of 3 plus 0 will be 3, 6 plus 1 will be the 7 with the emission of alpha. So what is left here? If it is 3, so 1 is left and 1 is for the proton. So how much mass is left? 7 minus 4 will be the 3. So this is the tritium. So in this way, you can balance the nuclear transmutations by the neutrons. And this is a neutron proton, and this is the neutron with the emission of the 2 neutrons. In the similar way, you can balance the equations. So the last one is the transmutation by the photons. So bombardment of the gamma rays and emission of the neutrons. So as we have said earlier, there is no change in the atomic number and the mass number. It will just excite the nuclide with the energy of the gamma rays. So there is no change in the atomic number and the mass number in the compound nucleus. So if one neutron is emitted, that means it is just going to decrease the mass number by 1, and there is no change in the atomic number. So 1 plus 0 will be 1, and 1 plus 1 will be 2. So, and the energy release in this process is the minus 1.67 mega electron volt. Again, minus value indicating that this is the energy is absorbed in this process. That means it is the endoergic reaction, or it is the non-spontaneous reaction. So this is all about the different transmutation by the radiations. This is the table in which you can take the different masses and calculate the Q value of any of the reaction mentioned in the previous slides. So thank you very much for watching this lecture, and see you in another lecture.